Kirchhoff's rules, physics, branch current analysis, a constant voltage source, V source, 5 resistors. Identify junctions, give them labels, and realize that Kirchhoff's rules, there's both the junction rule and the loop rule. The number of junction rule equations is basically the number of nodes, which we have 4, minus 1 for ground, that leaves 3. And for loop rules, there's simply 3 mesh loops, and that's another 3 equations, so we're looking at a total of 6 equations. Show flows through each branch. Label the flows, and even if you don't know the direction, just put a direction in there, but be sure to show the voltage drop as indicated by a plus to minus going with the flow through a resistor. First, our junction rules. There are 3 of them, also called Kirchhoff's current law. I could do any 3 of the 4 junctions. I'm basically looking at flow in equals flow out. For example, at A, I source in equals I1 and 2 out. Similar for the other 2. We have 3 mesh loops X, Y, Z. For each mesh loop, we go around the loop and look at the summation of voltage changes around the loop. This is KVL, Kirchhoff's voltage law, or the loop rule. So for loop X, for example, the voltage of the source is also the sum of the voltage drops across resistor 1 and 3. Similar for loops Y and Z. And now we solve the 6 equations for the 6 branch currents. Let's do a numerical example. So let's collect the coefficients of the branch currents in a table along with a column for the right-hand side. The first 3 equations are from the junction rule, and the coefficients of all of these currents are simply 1s, plus or minus, with no right-hand side. The next 3, the only right-hand side is the 54 volts, the other terms being the IR voltage Ohm's law drops, where I'm showing just the coefficients of the branch currents in the table. Now in Excel, we can solve this very quickly. We just want to multiply the inverse matrix of coefficients of branch currents multiplied by the right-hand side. And so we have our branch currents. With our branch currents copied into a branch table, we can use Ohm's law to calculate the voltages. I'm also showing the power calculation, volts times amps, to show that the power supplied equals the power delivered. And that's branch current analysis.